All right, so these are our learning targets we talked about. Okay, we'll graph and describe transformations of functions. And then I think you guys are pretty good at which family it belongs to, right? What were the families? Linear, quadratic, absolute value. Well, those we didn't really worry about. That was one, but constant was the fourth of the main ones, right? Okay. And then we have to graph some transformations. And then we didn't really get to the stretches and shrinks too much. We got to the reflections and then we kind of ran out of time. So I want to just kind of make sure we get through that. So just a quick review of our families here. Okay, maybe. And then remember, domain is our x values and range is our y values, okay? So again, our parent functions, those are the four main ones. And then this is what we wrote down as our notes, right? Okay, so if you weren't here, let's get focused, okay? So our constant is when we have a horizontal line through some number, okay? And these are our basic equations or functions for our parent function. Okay, those highlighted ones. If you see an x squared, you know it's quadratic. If you see the absolute value signs, you know it's absolute value. Okay, if you see an x in it, it's linear. If you see no variable, just a number, it's constant. Okay, and these are the graphs of our parent functions. You should know those four graphs. Okay, that way it's easy for you to tell what the transformation is when you graph a different one. All right, again, domain for all of these is going to be what so far? All real numbers, okay? Range for linear will be all real numbers. For the constant, it'll be y will be whatever f of x was, okay, whatever number it gives you. And then if it's a v, it's y is greater than or equal to. If it's an upside down v, it would be y is less than or equal, like our parabolas from last week, right? When it was a max, we had a range of y is less than or equal to. And again, our quadratic, same thing. If it opens up like this, like the parent function, it's y is greater than or equal to. If it opens down, because my a value is negative, remember, then it would be y is less than or equal to. So just remember the pictures, the graphs of our four parent functions that we're concentrating on here right now. And remember, if you're not sure, you can always make an XY table, right? And you're allowed to pick, since domain is all real numbers, you're allowed to pick any numbers you want for X. The ones we usually pick are -2, -1, 0, 1, and 2, right? And you just plug those numbers in for X into the function, and then you figure out your Y value so you can graph it. You also have a graphing calculator that does that for you, right? So you can look at it, and then you can look at the table of values through your graphing calculator as well. All right, so again, this family belongs to which family? Absolute value, right? All right, transformation changes size, shape, position, orientation of a graph. All right. A translation, that's a type of transformation. It just shifts the graph horizontally, left or right, and or vertically, up or down. It doesn't change size, shape, or orientation. Okay. So it's a basic movement, right, left, up, or down when it's a translation. Okay? So what did we learn again about these? You guys looking at your notes, hopefully? When it's plus or minus outside of parentheses, outside the variable, what happens? Come on, you guys should know this. This is what we actually did go over. What happens? Somebody said it. Goes up 4. Thank you, Cole. So this one goes up 4 when it's outside. All right? When it's not in parentheses or in absolute value signs, it's outside of it. You just do what it says. That goes up 4, so this one's going to go down 3, right? And then when it's inside, like this, look at the difference between that one and the first one. What happens? Left 3, or 4, sorry. When it's inside, it's the opposite direction you think. Okay? So that one's left 4. And this one would be right 3. So when it's inside the parentheses or absolute value bars, it's the opposite and it's left or right. When it's outside, it's what it says and it's up or down. Okay, that's what we learned on Friday, right? And again, just to review how to do this on our calculator. No, that's not the one I wanted. I want to let me grab it and move it. There we go. All right, so what's the parent function for this? Come on, somebody help me out. What's the parent function? What's f of x equal? X squared, thanks. Is that you, Tristan? Or Spencer? Thanks. All right, so if you want to use your calculator to look to see what happens, remember our parent function, and we just go for graphs, we hit the y equals button. X is next to alpha, hit enter, and then we can do, and it's already showing it here on the side, and here's my table of values, all right? Yours doesn't do that, but, and then hit x squared. What are we saying it's doing? It's going to go up 4, right? So when I hit plus 4 and hit enter, graph will have them both. Okay. Again, I don't know why. There it is. It should be showing both of them. So just moved it up 4. All right, so you can use your calculator to help you with this stuff, to visualize it. And again, to get the table to show up for you, what's it say right above the graph button in blue? It says table. So if you hit your second button and graph, it'll give us the table of values. All right? Y1 and Y2. Y1 is the Y values of the first graph you typed in, and Y2 is the Y values of the second graph. So you have your table of values if you need it, right, Taylor? Questions so far? Is this making sense? Again, this is all stuff we went over on Friday, but I wanted to hit the last couple of examples. And reflection we just kind of got into, and then it kind of ran out of time. All right. So what's the parent for this one? Just an x. Linear, right? And it's outside. So what was it going to do? What's the translation gonna do? Down 6, right? Because it's outside, there's no parentheses. Oops, don't say -6, down negative, just say down 6, right? All right, and then B, what's that family? Absolute value. Now, the -2 is inside the absolute value signs, so it's gonna go this way, horizontally, right or left? Right 2, the opposite direction. Okay, what do absolute values look like? V's, right? Straight, parabolas, curved, right, Callie? All right. Okay, so we started talking about reflections then, and then we kind of lost time. So it flips the graph over a line called the line of reflection. A reflected point is the same distance from the line of reflection as the original point, but on the opposite side of the line. So think about it like our axis of symmetry for our parabolas, right? That's how we usually got our other point, right? We reflected on the other side to get our third point when we were graphing. That's what you're thinking about, okay? So here is the graph, and it's the red one. I don't know why they... But this red one is the P of X one. Okay? There's our parent function, our parent V. So if I look at this point here, what point is that? 2, 2. And then I look at this point here, what's that one? 2, -2. It's being reflected about or across the x-axis. What happens to the y value? It's just opposite, right? So it just changes the y value to its opposite. Okay? We'll talk more about reflecting about the y-axis in a couple days. Okay? So, what's the family? We did this one too, but we did it real quick. What happens? Since it's negative out front, yeah, look at what we just did. The negative was out front. We reflect about the x-axis. All right? All right? Since it's outside of the bars, that's up or down. Which one does this do? Down how many? 3. Happy birthday, Caitlin, yesterday. You tired from the birthday party too much? Is that why you're zoned out?
Yes.
We'll zone back in. You're much older and wiser now, right? And then inside, we see a +5, so what's happens, Vincent?
It goes
When it's inside?
right side.
Left side. There you go. Left side.
Wait, why doesn't it go right?
When it's inside parentheses or absolute value signs, it goes opposite direction.
Absolute value just meant it's always been right. It's like absolute value.
No, but when we're just talking about the transformation part, when you see numbers inside, it's the opposite of what you think.
Okay.
When it's outside like this, it's what you think.
All right.
Up and down, outside, inside, right and left. Okay? So again, our parent function is this for absolute value, right? So reflex about the x-axis means it would be going down, right? Just flips it. But we're supposed to go down 3 and left 5, right? So down 3, 1, 2, 3, 4, 5. Left 5. So it's going to be this picture. Whoa. I missed one point. Sorry about that. So that's blue one goes with that function. Okay? It's reflected because of the negative out front. And then down 3 and left 5. Okay? And again, how do we find absolute value? How do I get absolute value? Come on. Nolan? Math.
And then you go to number,
Right. Right arrow to number.
enter.
And then enter. There's your absolute value. So we'll do our parent function. And then our g of x. So we got negative, math, number, absolute value. What was it? X plus 5, right? X plus 5, and then minus 3. Now hit the graph. There's our parent function, and there's our other one, our transformed one. Okay? Here's our table of values for the parent, and there's for our transformed one. And then there's our picture. Questions? All right. Last one that we didn't get to. All right. Which family? Quadratic, because of the x squared, right? All right. Outside of 4. So that means of 4, right? Inside a negative 1, right 1. Was there any reflection? Was there a negative out front? No. So no reflection. Okay, so remember, our parent function was 0, 0. 1 squared is 1, 2 squared is 4, right? Negative 1 squared is 1, negative 2 squared is 4. Oops, I got a point there. All right, so the red graph is our parent function. And then our blue graph, all these points go right 1 and up 4. All right, so this goes right 1 and up 4. 1, 2, 3, 4. That's my vertex. Remember, that's called the vertex. On your V's for your absolute value, that's the vertex, just like a vertex for our parabola, okay? So I went for my vertex right 1 and up 4. For this point, 1, 1, right 1, up 4. All right, for this point, negative 1, 1, right 1 and up 4. And then for 2, 4, I go right 1 and up 4, which would be 2, 9, right? Or 3, 9. And for negative 2, 4, I go right 1 and up 4. So there is our transformed parabola. I'm going to say transformation and parabola. Good word. Okay? So, just, did that help a little bit more after going over a couple more examples that we didn't really quite get to?
Yeah.
All right, so the homework assignment doesn't change. go back and do what you got. If you got it all done and everything made sense, great. But check it. Just go through and check your stuff, and you'll have your homework done, and then I'll give you, if you got it done and stuff, or get it done before we leave, if it's not done, I'll give you your 5 right now. And if you need help, just ask. So you can work together and get going on that. All right? Any questions? Yes. Yes. All right. Good job today.